Hello and welcome to the LUniverse Virtual Planetarium from Lancaster University. The following is a recording of one of our free live public shows that we ran during early 2021. I hope you enjoy.
Our solar system is an incredibly diverse place. It is home to 8 planets, 5 dwarf planets, over 200 moons, over 1 million asteroids, and home to nearly 8 billion people. So it seems only fitting that we start our tour across the solar system by the largest object in it, which so happens to be our sun. And when I say the sun is the largest object, I really mean it. The sun makes up about 99.9% of the weight of the entire solar system. In fact, it is heavier than the Earth, 1,305,693 times heavier to be precise. It is, of course, the centre of our solar system. All other planets, objects, asteroid moons orbited at different distances. But interestingly, the sun is so far away from us that if it was to disappear, granted it's not going to disappear, but if it was to disappear right now, it would take us 8 minutes before we'd even notice. That's because it is 8 light minutes away. So the light from the sun takes 8 minutes to travel all the way through space to reach our planet. Funnily enough, gravity actually works in a very similar way. It travels at the speed of light, a prediction that Einstein made over 100 years ago. So if the sun did disappear, even its gravitational effect on us wouldn't be detectable for 8 whole minutes. Quite remarkable, really. Those dark spots that you can see on the sun right there are called sunspots. They are regions of the sun that are a little bit colder than the surrounding area, and each one is, roughly speaking, the size of the Earth. The sun has these spots because parts of its incredibly volatile magnetic field get bunched up, which stops heat from being able to rise from the centre to the top as easily, basically slowing down its convection currents. We can actually use sunspots to help us detect how volatile the sun currently is. The more spots they are, the more bunched up the magnetic field, the more likely we're going to see coronal mass ejections, solar flares, other such solar activity, some of which can be incredibly damaging for solar communication, satellites, even potentially electronics on the Earth. After having a look at the sun, we'll head over to the first planet in our solar system. It is the one that is closest to the sun. It is Mercury. Mercury is named after the Roman god for speed, which you might know from the Greek equivalent as Hermes. It is, of course, the smallest of all of our 8 planets. It is the closest to the sun as well. It has a surprisingly long day, though, at 176 Earth days. And that is to have one day-night cycle. So not just rotate, but actually get to the point where it faces the sun at the same point again. In fact, that 176 days is so long, it's actually longer than its year. Its year is only 88 days. Meaning it's actually a day on Mercury is double the length of its year. If you were to somehow stand on the surface of Mercury and not immediately die, you'd actually notice that the sun looks about 3 times larger in the sky than it does here on Earth. Interestingly, because of its egg-shaped orbit, which we would call an elliptical orbit, the sun actually at points will set and then rise again. Being so close to the sun also means that it's an incredibly, just making sure that everything's still working here. I think so. Because it's so close to the sun, of course, it's incredibly hot on the day side of Mercury at 426 degrees, which is quite warm to say the least. But it's not actually the hottest planet. For that, we're going to have to take a trip a little bit away. We're going to go next to Venus. Now, Venus has a special place in my heart, and that's because it is the only planet named after a woman. It is named after the god of love, which you may know from the Greek equivalent of Aphrodite. Venus is actually quite similar to the Earth in some ways. It's actually roughly the same size and therefore has about the same gravitational pull. So you'd weigh the same on Venus as you would do on Earth. You wouldn't survive very long because of the atmospheric conditions and the acidity of it, but you'd weigh the same. So swings and roundabouts, really. Venus is actually kind of a weird planet because it rotates backwards. Now, I would say backwards, I mean in the opposite direction to how we rotate. So the sun rises in the west and then sets in the east. Although obviously space doesn't really care about which way you rotate, it does rotate backwards, but it also only rotates, I say, backwards very, very slowly. Its day is also longer than its year at 243 Earth days. Now, I said earlier that Mercury, although the closest planet to the sun, isn't actually the hottest. Venus is the hottest, and that's because essentially of the greenhouse effect. Very similar to the issue that's causing global warming here has caused global warming over on Venus. Its thick and incredibly dense atmosphere means the temperature on Venus gets up to 460 degrees, which, unless I have made a big mistake in my calculations, is actually hot enough to melt lead. So quite a remarkable planet. We'll take a quick break now from talking about the planets to move on to a satellite, a specific satellite, our moon, essentially our space partner. Now, of course, the moon is special, mostly because it doesn't go around the sun like all the other planets do. It goes around our Earth. It is, as most of you may know, tidally locked. And that means the same side of the moon always faces us. So we only ever get to see one half of the moon's surface. The other half, known as the dark side of the moon, which is a fantastic album, will never be visible from the Earth. The only way to see it would be to travel there. And that's exactly what humans did. In 1968, over 50 years ago, astronauts on Apollo 8 were the first humans in history to view the dark side of the moon with their own eyes. A common question actually is, how did we end up with this space neighbour in the first place? Well, one of the generally accepted views is that, big number incoming, which I always get wrong, 4,510,000,000 years ago, another planet called Theia smashed into the Earth. This massive collision with Theia caused rocks to splatter out into space. These rocks then combine in further collisions to form our moon. This means that the moon actually has a little bit of the Earth in it, making it a closer partner to us than you might have already thought. On to the next one. We'll head over to easily one of the most famous planets, known as the red planet and distinctively visible from Earth as a small red dot in the sky, beautifully visible at this time of year if it wasn't raining all the time. Yes, I am talking about the red planet Mars. It is named after the Roman god of war, which is Ares in the Greek equivalent. You may have noticed I do like my Greek mythology here. Mars is quite impressive because some parts of it are actually very similar to the Earth. It has a day roughly the same length as ours. It has a rocky surface, that's pretty good, and some ice near the poles. In fact, some recent evidence from science suggests that there might actually be small amounts of flowing water on the surface too. Granted, not drinkable water. Unfortunately, that's where a lot of the similarities start to stop and why Mars starts to become really hostile. If you were ever to go to Mars, not that I would ever recommend that you did, you would definitely need a spacesuit. The atmosphere is far, far too thin to breathe, and it's mostly made up of carbon dioxide. Next, after we all question why on earth you went to Mars in the first place, you would notice that actually you felt a lot lighter. You'd only weigh approximately a third of what you do here, which also means that you could jump 3 times higher. Not sure what you do with your newfound powers, but I'm glad that you've got them. You may also notice that Mars has 2 moons. They are called Phobos and Deimos, and I believe you can just sort of vaguely see them, well, at least one of them scooting by right there. Phobos is actually slowly falling apart, and in about 40 to 50 million years or so not for very long, will be destroyed by Mars's gravity and form rings around Mars quite similar to the rings around Saturn. Now, this is because of how gravity works. Gravity is entirely dependent upon mass and distance to the object. So the further you get away from something, the less power gravity has on you. But because of how close Phobos is to Mars in the first place, what you'll notice is actually the front side of it, the bit that faces towards Mars, has a greater gravitational pull than the back half. So Mars is literally ripping the front of one of its moons off from the back of it. Eventually that pulling will get stronger and stronger until it does rip it apart and form some rings. Pretty interesting. As we move further out, we're going to hit what is known as the Asteroid Belt, which is a collection of rocks in the orbit between Mars and Jupiter. Now, the asteroid belt, we'll come on to some misconceptions earlier, but we'll have a look at one of the largest objects in the asteroid belt, which is Ceres, which is this very dull grey rock here. It's actually named after the god of the harvest, which is Demeter or Demeter in Greek mythology. It is the only planet, the only dwarf planet made up of the inner planets. We'll come on to what a dwarf planet is a little bit later on when we discuss everybody's favourite Pluto, but it is the only one in the inner planets, and we class the inner planets to be essentially inside the asteroid belt. Ceres, this quite small rock, much smaller than the moon, makes up about a third of the mass of the entire asteroid belt. But here's something interesting that I only learned a couple of years ago. Take every depiction of an asteroid belt in every space film ever. Famously, let's take Star Wars as an example. And at one point, the Millennium Falcon is trying to escape and they have to fly through an asteroid field. And C-3PO quite loudly remarks that it's near on impossible to fly through it and not hit by a rock. Unfortunately, C-3PO, although normally quite clever, is incredibly wrong there. If you were to stand on the surface of a rock inside the asteroid belt and looked around, you wouldn't see any other rocks. That's not just because they're not emitting any light and they're quite dim. Even if they were being illuminated by the sun at that point, because the rocks are so small and so far away, you wouldn't be able to see any others. The asteroid belt isn't very dense whatsoever. Although quite large, things are very spread out. Space is an incredibly large place. Okay, we'll head a little bit further out now. And I believe we will actually head out to Saturn first, only because we was talking about rings a little while ago. Unless I have messed up my order here. I have not. I don't think. Hooray! Saturn, it is quite a remarkable planet and of course definitely the jewel of the solar system, as many people like to call it. Unlike Earth and Mars, Saturn does not have a rocky surface. It is mostly made up of gases, so that's hydrogen and helium in this case. It is a giant planet, so physicists have very creatively named this giant planet of gas a gas giant. Honestly, team, we need to come up with some better names for things. Saturn is literally just a big ball of gases all mixed together. It spins at a much faster rate than the Earth does. A day on Saturn is just over 10 hours or so. But of course, that famous feature has to be those beautiful, beautiful rings. Actually, well, to hear, most massive planets have their own rings, but none are as clear as Saturn's. The rings are also not solid objects, but made up of lots and lots of bits of rock. Some of these bits of rocks are about the size of dust, while some are as large as a house. The rings extend up to 282,000 kilometers, which is the same distance as walking all the way around the Earth 7 separate times. Yeah. Let's say you got into a car, you managed to go down the M6 and not get stuck in traffic, so you're doing 70 miles an hour the whole time. Impossible, but we're going to pretend we're science. And you managed to drive for approximately 12 hours a day. Not that I'd recommend that, but you did 12 hours a day every single day. It would take you roughly 208 days to drive from the inside of a ring to the outside of a ring. Quite a long time and certainly quite a large fuel bill. But even though these rings are incredibly long, they are exceptionally thin. The average thickness is about the same size as a 3-story building. Now, whilst that might sound large, you've got to consider how large these rings are. If, for some unknown reason, you decided to make a pancake the same size as the rings of Saturn, the Saturn's rings would be thinner and flatter than the pancake, which is an absolutely bizarre statistic and fact there. Saturn is also famous for having a large number of moons, many of which you can see zooming past and going underneath or behind those rings there. It currently has 53 rings with another 29 waiting to be checked, which gives it a grand total of 82 rings. Fantastic. We'll now head over to another one of the gas giants. In this case, we'll head over to very pretty Jupiter. Just like so. Now, Jupiter is a very, 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 very large planet. And when I say it's a large planet, I really, really do mean it. It is heavier than all of the other planets added together. Twice. So if you were to take every single planet, add them together and do it all over again, Jupiter is still somehow heavier than all of them. Like Saturn, it has a very large number of moons. It has 53 moons, with another 26 of them waiting to be checked. It has the shortest day at less than 10 hours. And of course, it is also a gas giant made up of hydrogen and helium. It's actually compositionally very similar to our sun, just a lot colder. In fact, really, Jupiter you could think of as just a very badly made sun. The only real difference between Jupiter and the sun is that the sun is a lot larger. As a result, had a huge amount more gravitational pull on it because it has more mass, therefore more gravitational potential energy. So it then got hot enough on the inside to start fusion, the powerhouse of the sun. So Jupiter is basically a start of a star that never got big enough to start fusing things, so never had enough energy to make it hot enough to continue fusing things. So either you can look at Jupiter as being this amazing, amazing ball of potential, or just a failed star. Totally up to you. The different streaks that you can see going across the surface there are different gases going around the atmosphere at incredibly high speeds, which is really quite impressive. Now, in just a moment or so, I'm going to have to look at this myself. We're going to see a giant red spot. There it is, a giant red spot appear on the surface. Now, that is creatively and uniquely called the giant red spot. Again, team, we do need to start thinking of better names. It is the largest storm in the solar system, and it really is very large. It is twice the size of the Earth, with winds stronger than any hurricane ever experienced on this planet. However, scientists have been telling us that the storm is starting to shrink, and even though it's been observed for 300 years so far, might one day die out. We'll take a quick detour whilst we're here at Jupiter to have a look at one of Jupiter's many moons, in this case, the moon Europa. A beautiful little moon right there. Now, Europa is actually one of our best candidates for life outside of Earth. This is because it has an icy surface, and underneath that icy surface, physicists believe that there are massive oceans of liquid water. Now, we are an incredibly long way off knowing if A, there is any life on Europa, or B, confirming that there is any life on Europa. But because of its conditions, we think there's a good chance there might be. And it'd be lovely to know that we are not alone in the universe. And it'll also be really nice to know that humans beings aren't the most intelligent things in the universe, because that would be quite depressing otherwise. There's Jupiter again. Oh, we'll go back to Jupiter very quickly. Because Jupiter, interestingly, can be thought of as Earth's planetary guardian. And by that I mean, it is responsible for keeping the Earth safe. I'll explain. Asteroids hurtling towards the Earth are typically diverted from us by Jupiter's massive gravitational pull. It also, because of its large gravitational pull, helps keep the asteroid belt stable, such that the asteroids keep in that orbit and then don't start drifting off either towards us and then causing quite a few issues. So yes, Jupiter in its majesty, sitting out there all by its lonesome, is incredibly helpful at keeping us safe. So we owe quite a bit of thanks to our large friend. Moving on, we'll have a look at the planet that everybody always questions the name of, and it does sound quite silly. There are many ways to pronounce it. I prefer Uranus. You could also go by one of the original pronunciations, which is Uranus, which I do think sounds cooler, or Uranus if you want to make some jokes, all fine. Just to clarify, it is named after the Greek god of the sky. It's an incredibly famous bit of mythology there. He actually is Zeus's grandfather, and Zeus is called Jupiter. So they are kind of next to each other in the sky, which is quite interesting. The many moons of Uranus are actually named after Shakespearean and Alexander Pope characters. So you have things like Juliet and Pip, which I think is really quite fun. But the most interesting feature about Uranus definitely has to be its bizarre rotation. Unlike every other planet, it rotates on its side. So 90 degrees from the plane with the sun. Sun's here, it rotates like that, going around the sun. Really weird. That means if you go to one of the poles and you live there, you can't, but let's say you did, you would have 21 years of night, followed by 42 years of night and day, and then another 21 years of day. We live up in Lancaster and we know what it's like to not see the sun for a few months. Trust me, I don't think I could manage with 21 years without it. Uranus, because it's such a far planet, has only ever been visited once, and that was by the Voyager 2 space probe, which basically did a flyby and then bounced off. We've not been back since. You may be able to see just about, it is quite faint. It's very, very faint rings. However, they are quite impressive rings because they are different colours because of the different rock compositions of it. An interesting planet, definitely. We'll now head on to the last planet in our solar system and the furthest planet from the sun, Neptune. Now, Neptune is named after the Greek god of the sea, which is Poseidon in the Greek mythology. It's a really odd planet, mostly because its the elliptical orbit of Pluto actually means that sometimes Neptune is even further away than Pluto is. Similar to Uranus, it's only been visited by Voyager 2. Being a gas giant as well, it actually has incredibly fast winds. If you were to get modern military fighter jets, which is quite hard to say fast, and put them inside the atmosphere of Neptune, again, not sure how you'd manage it, you notice that the planes no longer went forwards, but slowly drifted backwards. That's because the winds on Neptune are faster than our best fighter jets. An incredibly hostile planet, to be sure. Now, controversially, but there's no way you could do a tour of our solar system without talking about little old Pluto. Pluto, let's get my dates wrong, was reclassified as a dwarf planet in 2006. And so if you were like me and grew up at school being taught that Pluto was a planet, all of a sudden it no longer was one. It is very far away and very hard to see, so I have included here instead one of the beautiful images taken from the spacecraft that zoomed by, I believe in 2015, maybe 16, I think it's 15. This gorgeous sort of touched up image here, which shows that Pluto in all its majesty, including that lovely heart right there. Few facts before we go on about why Pluto isn't a planet anymore and why that technically is a good thing. Now, Pluto is the god of the underworld, also known as Hades in the Greek equivalent, and Hades rules over Hades, which always confused me. It's about 2/3 the size of the moon. It's a very, very, very small dwarf planet. And actually, Pluto has its own moon, Charon, spelled Charon for some reason, and that's large enough that Pluto and Charon actually orbit one another. Now, technically, the Earth and the Moon do that as well, but because they are both so small, they actually have an orbit center outside of the planet, so they really do go round one another. So the question is, which a lot of you may have had, is why on earth did we decide to drop Pluto all of a sudden? Well, be very thankful. If we didn't, you would then have to learn 200 other names of planets in the solar system. We reclassified it as a dwarf planet, partly because we found loads of other planets at a similar-ish distance of about the same size, if not bigger. So, to classify something as a planet, you need to satisfy 3 separate conditions. Condition number 1, you must go round the sun. Okay, Pluto has definitely passed that one. It does go around the sun. Thing number 2 that you must do, you must be spherical under your own gravity. As we can see in this lovely image here, well done, Pluto, you've managed that one. Basically, that means you're big enough that your gravitational pull has caused it to become mostly a sphere. The Earth isn't quite a sphere, it's a bit fat in the middle, but it's mostly spherical. So Pluto's nailed that one as well. Number 3 is where it falls flat. you must clear your local area of debris. And by that I mean, during your orbit, there can't be other objects of a similar size in the way. Pluto has a lot of objects roughly in its orbit of a similar size, and therefore cannot be classified as a planet, but gets downgraded to the rank of a dwarf planet. Again, there are about 200 other objects around the same size as Pluto at the same distance, so it joins its brethren there. Interesting though, Pluto is the only planet to be named by an 11-year-old girl. In 1930, an 11-year-old girl named it Pluto because her dad worked as part of the team that was discovered Pluto and was about to name it. He suggested it to the committee and it got approved, which is really quite sweet if you ask me. So this brings us roughly to the end of the tour portion of our show here today, as we had a very quick whistle-stop tour along our solar system. But of course, the beauty of this is that many parts of our solar system are accessible from the Earth. You just need to go outside on quite a clear, dark day. Granted, sometimes quite difficult, especially in winter, but when you do get those nice clear days, that you should be able to see quite a few different planets. Planets like Jupiter can be visible, Mercury is occasionally visible, and Mars is especially bright at this time of year. You can also see an amazing array of stars and constellations. Stargazing is entirely free and just takes a bit of time outside to do, and it's well worth your time. Thank you very much. Go ahead, Julie.
Drew, that was a really, really good show. So we are open for questions now. There's obviously already a lot in the chat, so I'll ask Andrew some of those. But if you have additional questions, you can keep typing them and we'll see how many we can get to. And I think what I'm going to do is pick a bit of a mixture of questions because there's a lot there. So Andrew, can you tell us, will our moon ever break apart like Mars's did?
Let me just come back in here. Here I am. Oh, I've frozen. That's a real shame. If you can still hear me, that's then fine, and I will figure out why I've frozen in just a moment. We'll just go to that for now. It will sort itself out in a minute. I can tell you why, if our moon will do it the same way as Mars's moon. I can confirm to you, fortunately, they will not do that. The moon is actually slowly drifting away from us. I think it's by about 2 centimeters, maybe 2 meters, 2 somethings a year. So not a lot, but it is slowly going away. So it's actually having the exact opposite effect. Our gravitational pull is not large enough to keep the moon next to us. So in thousands of millions of years time, we'll actually lose our moon entirely, which tidally might actually cause quite a few issues. Great question.
Thanks, Andrew. We've got so many great questions. The next one I'm going to ask you is, how can a planet be made of gas without breaking apart?
Oh, that's an absolutely cracking question. I cannot, for the life of me, get the camera to work, so we're just going to have to go without it, and I'll keep fiddling over here. I do apologise, everybody. Great question. Why does a gas planet stay as a planet? Well, it all comes down to gravity. So it's quite hard to remember that gases have mass, and by mass I just mean it has an amount of weight. So let's say you put it on a scale, it would actually show something, sort of. Air is actually really heavy. You currently have approximately a ton of air pushing down upon you. Granted, the air around that is also pushing it back up, but it does have a lot of weight. So you take something like Jupiter, made of hydrogen and helium, and it has mass. Granted, less mass than our atmosphere, but it does still have a lot of weight. As I said earlier, gravity is entirely dependent on mass and distance. So when you start getting a little cluster of gas, it will have mass, and therefore it has a gravitational pull. So then it brings in more gas. And because now it's bigger and has more mass, it brings in more gas, and then it's bigger, so it gets, and so on and so forth. It has a runaway effect. So the reason why everything doesn't just crumble into tiny little pieces so quickly is because it has mass, and that's what keeps it going. Really good question there. Thank you.
Thanks. Thanks, Andrew. We're getting in questions so quickly here. Why has no one been to the moon since 1972?
Ooh, that's a really fun question. I'm just going to do that and that. So this is, I actually really have a personal passion and interest in space lore because I'm sad. I need to get out more, but it's been locked down, so I couldn't. A lot of it comes. There's two main reasons. It's scientific funding and science availability in kind of a way. So the moon was an amazing feat of engineering and genuinely an absolute marvel. One of the most stunning achievements of human history. But in terms of what we can collect from the moon, a lot of it has already been done, and we can send probes to do a lot of things that the humans were doing. So it doesn't really make a lot of sense cost-wise to keep putting people on the moon. It's also exceptionally expensive to do it in the first place. So eventually it was deemed too expensive to do. And as a result, we stopped going back to the moon. Now, you may have noticed there's the Artemis program, which is the latest attempt from NASA to go back to the moon. And they're doing that such that they can then use the moon as a launching pad to get to Mars. And the reason we should do that is because once you're out in space, if you can then have a chance to refuel, it is much, much easier to get to other planets because you don't have to break through Earth's gravity anymore. So we're planning to basically make a space base, a bit like the International Space Station, but this time around the moon, and use the moon and all of its resources as a launching pad to get over to Mars. Great question. Thank you for that.
Brilliant. Thank you. Another one that came up, phrased a couple different ways, but essentially, how were the rings of Saturn made, or how did they form?
Okie dokie. Yeah, so it kind of forms in the same way that everything else vaguely formed. Aha! Hooray! If you push enough buttons, eventually things work. I can't believe that word. It's great. What's the best way to say this? Okay, so it worked for a moment and then stopped. That's a real shame. Oh well. It starts like this. The solar system originally was just a massive collection of gas and dust. The gas then formed the sun. A lot of it formed the sun, giving us an important part of it. The rest of the solar system were just clumps of rock. And in a very similar way I was talking about earlier with how Jupiter stays together, how gas giants stay together, you get a clump of rock, the rock has mass, the mass has gravity, pulls more rocks towards it, clump, 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 clump. In the case of Saturn, what is most likely to happen is that something broke up. So something was trying to form into a moon or something like that, and because of a collision or because of gravitational effects, something like that, it got smashed apart and then formed a rings. So if you actually have a look at the rings of Saturn, they look a little bit like a mini solar system, right? You have things orbiting Saturn, and Saturn can act a bit like the sun. So it essentially works in the same way that our solar system does. You have a large gravitational body in the center and lots of little bits going around the outside. So that's one of those there.
Thank you. These are great, Andrew. Another question that has it was asked quite a while ago and has had a lot of upvotes. So how is the moon tidally locked?
Oh, I wonder if my camera will stay alive.
Maybe you could explain a little bit what tidally locked means.
Yeah, that's absolutely fine. I'll give this. This is going. I'm going to give up on that now. It's quite a difficult one, which is a shame. But I will give it my absolute best go to try and explain it. Okay. Yeah, I'm really not doing well. So you've got something's tidally locked means the same side always faces you. By that I mean the time it takes for the moon to orbit the Earth is the same as it takes to have a rotation. So as it starts moving around, it rotates such that the same point is always facing it. So it's not that the moon isn't rotating on its own axis, it is, but it's rotating at the same period of which it orbits. So it's actually about 28 days or so. It's not exactly, but it's about 28 days, about a month. it's tidally locked because of gravity. So the gravitational pull of the Earth is strong enough that it has essentially slowed down the rotation to the point at which it matches its orbit. Essentially, you can think about it as, this is where it started to fall apart a bit. If parts are slightly further away from the Earth, they will experience less gravity, whilst parts are slightly closer will be a bit stronger. And you basically get this balance of two forces, one trying to pull it towards, one slowly seeping away. Energy-wise, it is simpler for it to match, and eventually that is what happens.
Thanks, Andrew. Will the sun ever freeze?
Ooh, that's a great question. I like that. Will the sun ever freeze? No, the sun will not freeze, fortunately. So our sun isn't that big. It's quite a small star. It's not going to go supernova. It won't turn into a black hole. It will just sort of expand, have, for lack of a better term, a space fart and die. But it will do a few stages before that. So the first thing it will do, I'm really sad I got my camera, I'm waving my hands around a lot. The first thing it will do is expand into a red giant, and that will happen when it starts to run out of hydrogen to burn into helium. So our sun is not big enough to fuse helium atoms together. It can only fuse hydrogen atoms together. Okay, so it tries, kind of fails a little bit. If eventually it runs out of hydrogen, it only has helium. The sun expands. I won't go into all the details, otherwise we'll be here for hours. It starts to expand into a red giant. That red giant will actually be so large it will engulf the Earth completely, destroying our entire planet. Eventually, it will then actually be able to, it will get hotter and bigger, and eventually be hot and big enough to start fusing helium together. But eventually it will stop being able to do that. Large solar winds will be generated. It will then expel most of its outer layers and be left with a white dwarf star. So no, it won't ever freeze. Well, it won't really ever freeze. It will just turn into different types of stars. Eventually, the universe will end. And when it ends, there's something called the inevitable heat death of the universe, which is where after genuinely trillions and trillions and trillions of years, silly number, all vibration stops and atoms break apart, and then there won't be any more heat. But that's not really going to happen on a scale that we care about.
Yeah, we'd rather it if the sun kept on shining for a while. The next question will go a little bit further out from the sun. So how come, since Mercury is the closest to sun, why is it not the hottest?
Yep. Cool question. So we'll just retouch on the point that we made during the show just then. The greenhouse effect, really, the exact same one that is causing global warming here is the exact same reason that Venus is hotter than Mercury. So it's the heat from the sun gets trapped inside Venus's atmosphere. So rays from the sun penetrate the atmosphere, they enter, they bounce about, and because the atmosphere is so thick, it can't then get back out again. Again, I'm waving my hands around like a lunatic. It can't then get back out again, keeping the planet really, really hot. Unlike Mercury, that doesn't have a thick atmosphere. So a lot of the heat is just dissipated. It just goes back out into space, it just bounces off, whilst at Venus, it all gets trapped, thus making it hotter.
Thank you. Thank you, Andrew.
You're welcome.
Another question. So now we're thinking about Earth again. Is it possible for the moon to collide with the Earth again?
Oh, that's a good one. I like that. And let's see if the camera has solved itself. I should stop trying. Maybe. Okay, fine. I'll use it whilst it's working. Hooray! No, not really. Because, as I mentioned before, the moon is actually slowly going away from us. That, as a result, means that it's not going to come on a collision course. It's actually quite orbitally stable. So the gravitational pull on the moon has locked it into quite a stable orbit around us. It's not an orbit that's decaying. There is absolutely no reason that it should ever fall into the Earth unless another body came past. It would have to be an incredibly large planet, for some bizarre reason, came bombing through the solar system, came in between our orbit of the moon and the Earth. If that ever happened, one, it would cause untold chaos on our planet, and then it could possibly disrupt the orbit of the moon to collide with us. However, the chances of that happening are so slim, so slim, it's essentially zero. That's a really fun question. Thanks for that.
Thank you, Andrew. Thank you, Andrew. We're getting questions in faster than I can even read them at the moment. So I apologise, I'm doing my best. So could you tell us which planet has the most moons?
Yep, I absolutely can do that. That's a nice easy one. It is Saturn. It's Saturn. It has... No, I froze again. That's such a shame. It has 53 moons confirmed, with another 29 waiting to be confirmed, which gets us a grand total of 82 moons.
And
Saturn, sorry, go ahead.
And how would you check those extra ones that haven't been confirmed yet?
I will defer to your expertise on that one, Julie.
Fair enough. Really is to do with understanding whether the moon is really going around the planet, because if it's not going around the planet, then it's not a moon. So we need to measure its orbit. So we'll need to measure the position of the moon with time to see if it's moving in a way that means that it's going around the planet, and then it would be a moon.
Thank you, Julie.
Of course. So go on. So let's find another question here. And I'm getting so lost and confused because there's so many of them that are great. Which is denser, a gas planet or a rocky planet?
Oh, do you know, I've never been asked that before. And well, a rocky planet will be denser, simply because of the way the material density. But it's not to say that a gas planet couldn't be denser because of how tightly packed you could make it, and because of the heat and the I can't think of the word I'm trying to say. Essentially, whilst a rocky planet inherently would be, let's say, denser because of the way in which solids work, you could actually compact gas into a very, very small area. For example, as I said earlier, the Jupiter is quite compositionally similar to the Sun. The Sun is just a ball of gas, and that's exceptionally dense. And the densest thing in the universe is a neutron star, or a black hole. We won't go into those for now. Is a neutron star, right? So yes, inherently, a lot of the rocky planets are denser, but a gas planet could, in theory, be denser depending on how much gravitational pull has pulled the thing together. I hope that's semi-clear.
Yeah, that's great. Thank you. I think we're in our last sort of minute now. So I'll ask one more question, and then we have some questions for you guys that are watching. So what would happen? No, we've already asked that one. How can a planet be made of gas? No, we've already asked that one, haven't we? Sorry.
Black holes?
We're talking about planets today, not black holes.
Fair enough.
How did the water on Jupiter get there, and why hasn't it not fallen off?
Okay. Personally, I'm not aware of water on Jupiter. I don't know if there is large amounts of water. I'd be quite surprised, really. Compositionally, you could have all the different parts that make up water. It's H2O, right? So it's some hydrogen, some oxygen knocking about. I don't believe there would be water in the sense that we would know it as in liquid water. You could probably get water vapor. So it's gas form, like clouds, essentially, orbiting the planet. But the same reason it doesn't fly off into the solar system is gravity and the atmosphere of Jupiter being really, really thick.
Thank you for watching, and I hope you enjoyed learning a little more about our amazing universe. Our team from Lancaster University also runs shows for schools, community groups and more, both in person with our portable inflatable planetarium and online. But any in-person events are subject to current COVID restrictions. If you're a teacher, community group leader or part of a similar educational organisation, please do get in touch. We're particularly keen to make connections with those in our region of Lancashire and Cumbria, but we'd love to hear from you wherever you are. But for now, take care and keep learning more about the amazing wonders of our night sky. Thank you.